Morning,
Hello,
Mr.
sir.
Morning, sir.
Good morning, sir.
Okay. So I think we can start now. Is everyone already here? Or we can wait for a few more? How many participants now are in the list? We have, okay, 34. I think almost everyone are here already. Okay. So if we'll share you my screen. And how are you? How is everyone doing? You're doing fine, right? Like you're still working from home, like studying from home, and take care of yourself well. Can you see my screen? I have shared you.
Yes, sir.
Yes, sir.
Okay. Okay.
Yes, sir.
Sir.
So okay. So for this week, we will learn another topic called pointer. And from the previous week, what we have learned, it was about recursive function, right? I think everyone have learned, and I hope when you have reviewed it for some times. And if you have any question, you can ask me. It is fine. Like, I think without further ado, I will jump to the topic for today. We will learn on pointer. Just to make sure, like just to confirm, like is everyone have learned about pointer yet?
Yes, sir.
During your class, you have learned it one time. Okay, and I hope like some topics maybe what you have seen before, but perhaps some of the points that I have prepared here, maybe you can take it as an additional lecture note for yourself. And here we will talk about the pointers, and we will apply some practice using C++ language. And as you seen on small pictures on the right side here, there is a representation between a connection from one box to another box. Okay, so the blue one here is called like kind of pointer variable, which is used to point to another variable. And another variable here, we have the green one. And actually in the memory address, each variable, it has the address and also the value that it stores. For example, if you say a variable integer n, and then when you create it in the program, and what it does is to create a block in the memory. And if you set a number, it will store in that location. Okay, so it is referenced by the address normally. Maybe not talk much on the brief part here. We will jump into the outline of the content today. We'll see several points. Before getting into pointers, we will have a basic understanding on the computer memory address and how the variable is stored. Next, we will follow about the part of pointers. What is pointer? What is the advantages? And how we can use that. And before we finish the pointer, we also take a look on the pointer, like we combine it to use with the array. Okay. Before we access to the data in the arrays using the bracket syntax. But with pointer, we can have an ability to access to array elements without using the bracket. And last but not least, we will see the example along together. So we will start from the very introduction part. We will talk about the computer memory address. Okay? And this is the important part. Before we can understand the pointer well, we should know about the memory address. So in a computer memory location, it actually has the what we call is an address, and that particular address it store content. So it somehow we store our value, or sometimes we say our data is stored in the memory. We create a variable, we set some numbers, some data. For example, it's a string, it is a character. We put it inside the memory. Okay? But how can we get those data? We can perform it using the address. Okay. But when we create a variable using integer, for example, integer n here, we just say the name of variable, and then we can manipulate the data, the value that is stored at that location. And normally the address is numerical number, which is expressed in the hexadecimal. Okay, this is base 16, right? Maybe everyone has learned about base system. We have base 2, base 8, base 10. This one is base 16. Okay, and in the memory, as you can see in the representation here, we have the address, and we also have the value. And at this specific address, what value is stored? It is just how it is represented in the memory. And for example, the integer values, it normally takes 4 bytes of memories. But in the older in the dates, like it can also, it actually also up to 2 bytes only. But now, because the specification of the hardware is increasing, and integer value can consume up to 4 bytes of the memory. In the lecture part, we also testing how we can obtain the memory that each variable type it takes using the C++ language. There is a command that we can use. For example, what is the size of integer that it can store maximum, and the other type that we can also access using that certain command. Okay. We see it later. And next, we will discuss about the variable in computer memory. Each variable that we create in the program here, it's stored in a location of the memory. This is referenced by the memory address. And the value, for example, when we set certain numbers, this number will be put at that location. We use a memory location, and next we put that number into that location. And for example, if we want to know what is the address when we create a variable, say n, and we want to get the address where this variable is stored in the memory, we can use this symbol, the ampersand here. It will give you the address of that variable. So this is just an example. If you say name is a variable, and then if you put this symbol preceding this variable name, we will get the address of this variable. A very basic example, you can simply create an integer variable here. Let's say put integer n here. And then in C++, it's very simple. We can just use the command cout, okay, cout here. And then you put this symbol n, and then you put the variable name. That's it. This is how we can access to the address of this variable. But if you use C language, because C language, we can display this specific string directly. Because whatever we display, we use the printf command. We need a placeholder, right? You have seen a %d, %i. This is just an integer number. Float, %f, character, %c, and for sequence of character, which is a string, you put %s. This is for C language. Okay? C language. But this one, it cannot be applied to the address. You need certain format. In case that you use C language, it's somehow called like P or P or X, I'm not sure. period x or period percentage x or percentage p. Okay, you can try that if you still use the C language, but it's in the C++ syntax. It's very simple. Just put this using the cout command here. We will try that later on. That is okay if you could not remember this command cout here. We will do it together, test it in the program. And next, we come to the introduction part in the pointer. What is pointer? Pointer is actually a variable that it stores the memory address. And this memory address is actually belong to another variable. So to make it simple, pointer is a variable that store memory address of another variable. And it used to point to that variable so that we can access to the value, also the address of that variable. So if you take a look in this picture, and the pointer here. So when we say no variable here, it represents the normal variable that we use to create before we learn pointer. Let's say you have character, you have string, you have a number, integer. That is called normal variable. But when you have pointer, normally pointer is represented by this symbol, this star symbol. It will point to another normal variable here. This is the overview of how the pointer is used. And for example, in here, as you can see, there is a normal variable on the left side. This is a normal variable. It has the address. For example, this is address. As we have discussed, it is represented in the hexadecimal. Hexadecimal also including numbers from 1 to 10, and then A, B, C or something until F. And this is the value of this variable. And when we have the pointer, if we point, we can write some command, just assignment operation. And then it can point to this variable using the pointer operator. And what does it store here is actually, if you take a look on the green and the red color here, this is the green color and the red color here. They're actually the same, right? For the normal variable, it is useful telling, okay, this is the address of this normal variable. And for the pointer, this value is taken to store in this box. This is the value that the pointer store. As we say, the pointer is a variable that store memory address. And the pointer itself, it also have its address. Okay, each of every variable have its own address. So in this case, the pointer point to a normal variable. So it also have its own address, the pointer here, and the value that the pointer store here is the address of another variable, which is 1001 here, the variable or the address of the normal variable. And if we say about the content, the value of this normal variable, it is 50. Okay. And using a pointer operation, we can get the address of this variable and also this number. Okay. So it provides the two options that we can access to the address and also the value of that address. Is everyone have any questions so far? If you go too fast, you can stop me a little bit.
No, Mr.
No, sir.
Okay, no. Okay. If you had no question, we can go a few more slides, and we will back to the practice a little bit, just to summary what we have learned slowly here. Okay. And next we will see about the differences between the pointer and the normal variable. Actually, we have talked detail already in the previous slide. Normal variable is actually used to store value, while the pointer is used to store the address. This is the main difference. one normal variable is used to store a value, and pointer is used to store the address. Normally, pointer is a representation of address. There is a number called hexadecimal format, where the address is used for each variable. And we can have a pointer to any variable type. As I put here, we can have a pointer to any variable. That means if we have integer, we have character, we have string, we can create a pointer which is the same type. If we want to point to string, we should create a pointer that is a type of string so that we can point to string. If you want to point it to the integer, we should create a pointer variable, because pointer also have its types. We need to define it as an integer also. But there is one special case for the array. Array is also defined as a pointer. We don't need to use the symbol and, same symbol ampersand, in order to access to the address. And we will see it later in the following slide. So as you can see on this picture, we have two variable, normal variable, and we have pointer variable. Each variable have its own address. Okay, this is the address of normal, and this is the address of the pointer variable. And if we take a look on the content, the value that each variable store, the normal variable is stored just a fixed number here, and in the pointer variable it stored the address. So because it reference to another variable, it should store the address on another variable. And if we don't make it point to any address, we can just simply, there's an operation, we call it null pointer. We can put this is just a constant. It's saying that, okay, the pointer does not point to any variable, any location of the memory. And using pointer is quite confusing sometimes. If you point it to this wrong location, for example, you're trying to access to a variable in your program, but there is a mistake in your coding logic or something. You point it to another location of the memory, and in that memory location, it is used by another program. Okay, let's say a program A use that memory location, but in your program, and you write a pointer, you point this variable, accidentally point to that memory location, which is used by another program. And when you try to modify something, it will cause the other program to crash, because some value is updated and that number should not be placed there, like it's our scope and our limitation. Next, we will see the advantages of using pointer. In pointer, it uses less memory because it gives us the dynamic memory allocation. And mostly when we use pointer, like there is a basic operation that we can just perform with primitive data type, integer, character, string here, just to manipulate data, access data from pointer. And another thing is we create a more advanced data structure. We have the linked list. Probably you haven't started the lecture on linked list yet. Maybe next 2 weeks you will learn that. We have linked list, we have stack and queue. Those advanced data structure needs the pointer operation, and it use a little bit different from the basic primitive data type. And with pointer, it allows us to run the program faster, but it can give us the confusion. For example, if you point it to the wrong location, the program will not run faster. But if you use it in the right way, okay, it will increase the execution speed, and also reduce the execution time of the program itself. And another advantages is it provides a way to access the array element. In the array, when we use the traditional way, we access it using the bracket, right? We have bracket something here, and you pass a position. Let's say you have an array A and you want to access to the first element, you say A bracket and 0, right? So if you use pointer, you don't need to use this operator, okay? No need to use this one. just follow the syntax of pointer, we can access to the data in array. And another advantages is in pointer, it does not copy the data, it just point to the existing data. What does it mean here is that, for example, if you create a variable before you use pointer, you create a variable, say n1, okay? If you have an integer n1 here, you say number 10, okay? And later on, you want to have another variable which also have the same value. You say n2, which is equal to n1. So what it does here, it make a copy, right? This is to make a copy. Making a copy here will take you some memory space in your program. But in pointer, it does not need to create a new variable here. No need to create here. It just create a pointer here. Let's say I have an integer here. It is represented by star symbol, and I say p here. Okay, and then we put some operation to make this p pointing to n1 by just using p equal to this symbol n, and then you put n1. Okay, this is the address of n1, right? And then you put it to store in p. Okay, so in here, if you point to the n1 directly, it does not make a new copy of this one. It's not the same as this one. It just make a pointer pointing to this variable in the memory. And if we want to have another variable copies, we just make a new pointer, right? New change the pointer here, point to another variable. Okay, this is just the way how it works. And raise it a little bit here to make it more easy to read. And the last step is the function. For example, if you learn about the function before, you can take advantages of using pointer. When you create a function, there is only one value that can be returned from the function itself. Whether it's an integer, it is a character or string, or sometimes you define a return type of the function to be a structure, because a structure can hold many data type, right? For example, I create the structure student. The student has ID, have a name, have phone number, have email. There are several combination of data types that can be combined into a structure. And then you can create a function to call a structure, okay? But only one structure at a time that can be returned from a function. But if you use a pointer, you can return more than one variable from the function. This is done by what we call is passing the parameter of the function as the reference. We call it pass by reference. Passed by reference. Because pass by reference allow us to access directly to the location of the memory. And when we want to modify some value, it is possible to do that directly on the memory address. And just the thing here is like, if you want to return, for example, five value from the function, you need to provide 5 parameters, and each parameter is the pointer. That is the pros and cons of using pointer. You need to pass more parameter into the function, but it is possible to return more than one value from the function itself. And next, we will talk about the two main operators that we can work with pointer. These are commonly used operator. We will see it a lot when we use operation with pointer. We have we say reference operator. When you heard the reference, it's you think of a symbol like here, like the ampersand here. This is for reference, right? This is a reference. You reference to an address. This gives you the memory address of a certain variable. But when we use another symbol, we call it star. Okay, this is the two main symbol used in pointer. You have n and you have a symbol star. the symbol star here, which gives you the value. For example, the value of an address. What is the value stored in that location? So in this one, what we call is different. Okay, this is just similar term. We call it different operators or value operator, or another one is indirection operator. It gives us the value. Okay, this one is value. Value is like 5, 6, or specific string, static string. But if you say reference, here is an address, hexadecimal format. For example, as you see here on the left side, you could add this is how you create a pointer. It's the same way as you create the variable. Just add the symbol here. Just make a note here. The star here, and we need to put a star symbol. But when you say a star here, this is when you do operation. Okay, we say about the operation earlier, right? The operation means you perform some like arithmetic operation. You sum them up together, or you do some other formula, or you display a value. So this one, you make a pointer using a syntax of pointer, and then you create a normal variable. Let's say n equal to 6. And next, this is how you use a pointer, because pointer store the address. And here, what you assign to the value of p here, you assign the address, right? Whose address? Address of d. Okay. Example, you have d here. Let's say d. This is variable d, and you have let's say address is 1 ABC, and the value here is 6. Okay. And when you say p equal to address d here, you just get a p here. P is actually also a pointer and also his own address. Let's say AFD is address of pointer, and what is stored here is it takes the address of D to store in P, right? So what is the address of D is 1 ABC. So 1 A B C to put here. It's the same as what we mentioned here is like this one point to this one. This is the meaning. Okay? This is the meaning. You have D and you have P. Okay, so P, it have it address also, but it store the address of D, because we say we put the address of D to store in P. Okay? And finally, we can display the value that this address store. For example, if you say P, star P here, if we will reference it access to the address, this is the address of the P store. What is the value? It is 6, right? So this one will give you 6. But if you say only P here, no star at all, it will only give you the address where the P store. Okay. I think to make it little bit more to understand, I will skip the slide here. We will go to the testing program a little bit, just to demonstrate. Okay, start here. You can also open your tool, like you use this II C++, you can open that and create a new program here, just as a test. Maybe say it's pointer 1 CPP. So first of all, we need to write the syntax of the C++, the structure of the program. So I will use IOStream here using namespace. If you have the traditional like syntax as C, it's okay. But normally, if you use C++, I recommend like you use syntax like from C++. It can take advantages. For example, you can use string syntax. You can display the address without using the specific placeholder. So we say here the variable ends. Let's say the value is 6, and we have another pointer variable. Star P here, it's a pointer. This is a pointer variable. Variable. This is not more variable. and both of them are actually integer variable. Pointer also have its types as we has discussed from the previous slide. So in here, if you say cout p, okay. So from here we haven't assigned any value to p yet, right? We just create two variables. First one is normal. The second one is pointer. Next, we can set value to p. Let's say p equal to address of n. Okay. So we take the address of n and then we store it in p. Okay. And you can see out p here. So if you see out p, this means that you're trying to display the address only because p store address. So you say here p, it will give you the address. And one more operation, if you see out star p, we have discussed, star is talking about the value. So it will access to the value that the address that is located in that address, which is the number 6 here. So I will put the new line here a little bit to make it easy to read. Okay. We run this one. Okay. So this up from this output, we have seen that the value that p store here, this is the value that p store. It is not the address of p, but the value that p store, because at line number 10 we say p equal to n ampersand n, which means it takes the address of n and store in p. So this one is actually the address of n. Okay. And what is the value if we access to the value at this address? What is the value? It is 6, right? Because this is the address of n. So if we take about the value that it holds, that it contains, this is number 6. Okay, this is the output. And we may try a little bit more here. Let's say cout. We focus on n. Okay, when we say address n here, and if we cout address of p, okay. So in here, this is the address of n. It should be the same what we write here, right? It's p, right? So whatever we display from line 12, it is the same here because they're the same, the address of n. But if you say address of p, okay, this number should be different from above, like we haven't seen it before, because this is give us the address of p only. You can run this one. Okay, as you can see here, this is the about 2 lines, 12 and 13. This is give the address of n, which is now stored in p, and this is the value at that address. Okay, and we have another display here from line 15 to 16. Okay, at line 15 we give the address of n. Okay, this is the same as when we say display p because they are the same thing from line 10. Okay, we set it to the same value, and at the last line of codes, number 16, this gives us the address of where the pointer is located. Okay, this is the address of pointer, not the address of variable n. Okay. Do you have any question so far here?
From me, no, sir.
No question. Okay. I think it's okay. It's not that difficult. From here, we can do certain operation. Let's say I say cout here. If I say cout n, this will give us the value of n, right? Which is number 6. Okay, you can run this one. Next, we will do some operation using pointer to modify this number. So the value here is 6. Okay, this is correct. This is the number of n. So in a point of time here, I say something star p equal to 10. Okay. When we say star p, this means that we are trying to access to the value at that address that p store. This one we are trying to assign number to this location, right? So we put it 10. Okay. And finally, this one we will obtain 10. It's not 6 anymore. because we modify directly into that address. Okay, as you can see here, the number is now is changed to 10 because by using the command at line 15, we modify some number using the pointer operator. Okay. This is the value, right? We're trying to set the value into this one, okay? Because it's a value. We can also say, okay, star p plus 10. We can do that because this is also a number. The previous number is 6, right? Where that p is point to, the content as that address is 6. So you say 6 plus 10 is 16. 16, then you assign to this location, okay? Because value operator, you update something and you put it back, okay? So now we get it's 16. All right, okay, we get 16 here, okay? Because of this operation, we get the old content plus 10 and then we put it back. Okay, I will not go further into the coding here. If you have any question, you can ask. If no question, I will go to for the next slide.
From me, I think all clear, sir.
You can continue, sir.
Is okay. Yeah, the experience like some student they what they confuse is here they put when we create here we put star p, right? We put star p here. This is how we create a pointer only, how to create a pointer. And when we use, if we put p, it is telling us that we're trying to show what is the value of p, because p store address. So this value is now the address. When you display it is address. But then you say star p, okay, this one is different from here, not you ignore this one, no need to reference to the how we create it. When we say star p here, we try to access the value that the address store at p. P store, let's say p store ABC address. And when we say star p, it means that we will take a look at that address that p store. Let's what we just say now, ABC. What is the value at the address ABC? Okay, this give us this value. Star p will give us the value is a value, not address anymore, but value from where? Okay, from that address that p store. Okay. Let's start to learn pointer at first. They confuse. Okay, when and when you put only p here, no star at all, it is address. Okay, I think I will jump back to the slide if you don't have any questions. Just a way we write some certain algorithm. Pointer is a Hello. Can you hear me? I think I have
Yes,
have
yes,
lost the
sir.
Yes, I
connection.
can.
Hello, sir.
I can, sir.
Okay, okay. Sorry, I think I have lost the connection. And you can see my screen, right?
Yes, sir.
Yes, sir.
Okay. So any questions so far on how we create a pointer and the way we access to the value of pointer and also the address? Okay, I think it is okay. We can move on. Just in here, it just gives you the pseudo code how to create a pointer, like the way we write algorithm before we write into a certain language. So if there is the command that you are not familiar with, okay, it's okay. Just a traditional, like it is an easy way, like there is no format at all. Just what we say that how we can create a pseudo code so that everyone can understand this one. A pointer is actually a variable that must be defined by specifying the type of variable. Because as we can see that when we create a pointer, just now that we put a star something, right? And then you have the data type here. When you say in C language, C++ language, you put integer here, and you have a variable, let's say n here. If you wanted to make it pointer, just put star, okay? And this is the name of the pointer, right? The name of the pointer. This is just actually the var keyword. What we focus here is the data type. It must need a data type. So a data type here, it can be an integer, it can be a character, a string, and also be a structure itself. Okay, the structure can also have the star pointer. Mostly when you work in the stack data types, you use a linked list, you will need a pointer with a structure. Okay, and then from the left side here, it just gives you the structure, how we create a structure. We give a name to a structure, and there are certain properties, some member that we create inside the structure. And next, what we call here is pointer initialization. Okay? Initialization means just to if we don't make the pointer to point any variable yet, we should make it to nil. Okay, so nil here is special command. It's a constant that allow us to disable the pointing pointer to point to some variable. We don't point it to yet, so we just put it to nil. You can create it by using this command. You create a pointer variable and then you set it to nil. Okay. If you don't know what variable that this variable pointer should point to yet, just put it to nil first. If some certain of time that you in your program you want to make it because of certain condition, if and else, you can put this pointer point to another variable. And also when we want to point it to the variable, I think we have seen in the same example already. We use this is a normal, right? Normal variable. This is a pointer because it has star. Both of them must have the same data type, whether it's character or integer or other types, so that it can point to each other. Okay. As you can see here, we create a pointer variable. This is a normal variable, and next we make the pointer point to this variable d here. This is the most common way that we oftenly seen in the pointer operation. And we will have a quick note here about the reference and different operators. The symbol, special symbol here when we use with pointer. So the symbol n here is to get the address of variable. Address here can get from normal or pointer. We can also get the address. And when we use star, it means that we are trying to work with pointer and then we access to the value that the address of that pointer store. Okay? example, the star here mean, for example, you say P here, you have P. P also have its own address. Let's say 1A, B here. And what is stored is the address of another variable. I say A, B, C, D. Let's say we have another variable here, A, B, C, D. Okay. So this means P point to here, right? So this is, let's say, N. Okay. If I say N here is the number is 7. Number is 7. So when we say star, it means that it it take a look at P address. Okay. What is the value at this address? Okay. So when we take is the address, it is the address. The value here is 7. Okay. That's how the star symbol works. And you can see in the example on the right side here, we create two variable. One is pointer, another one is a normal variable. And a normal variable, we assign a certain number right here. We say C equal to 5. Okay. So here, this is just the representation of the memory. You have the P. You have the PC here is a pointer. You have C here, the value now is 5, and it has the address. Okay. And on the right side here, it's just a representation. What is the address here? Because this is too small. This is just gives you the address of the C. Okay, we use N symbol here, and the value that C saw is 5. Okay, so PC here, there is no content in here yet. It does not store anything yet because we didn't write something to put address to this pointer, right? But in the next step, here, we put some address into this variable by using this symbol. And here we take the address of C to store in PC, right? PC is a pointer. So now PC here now is storing the address of C. Okay. Address of C here, this is the address of C. We put it to store in the PC variable. So now PC, what it store is the address. And if we talking about star symbol, if you say star PC here, it means we're trying to access to the value that this address is located. Okay, this address is here. This is the address here. And what is the value at this address? It is 5, right? So when we say star PC, it is number 5. Okay. And next, we write some line of codes in order to update the value of C. This is the value of C. Now it's changed to 11, right? So before it is 5. Here, before it is 5. Now it is changed to 11. Now it is changed to 11. So that means that either from C or PC. If we use star PC, the value of this one is 11, right? It's the same because this is one way to like certain way to access to the value at C. Okay? And another way is we update the value of C by using pointer here. Because now I update it to 2. Let's say 2 put to the star PC. This means that star PC before is 11 because now we set it to 2. Now it become 2. Okay. So either we say PC or we say C. We can update to the value of C using a pointer operator. This is just a quick recap. We have seen this in example already when we code along in the program. We can update the value of N by using star P or something, right? In earlier. On how we create a pointer, and we do some checking address of each variable. Okay. So in here, what this is very simple. We create a normal variable. And next, we create a pointer. At line 7, we store the address of the normal variable to P. Okay. So it means that when we say N here, we create a variable. It's just like we define a variable N, and inside the memory, it has the address. What is the address of this N? And what is the value it store? It is 10, right? Because from here, we say the number n, we set the number n into variable n. And next, when we say p equal to n here, p equal to symbol n and the variable name n. So this means that p also have address, okay? And the value here is the value, the address of the n. This is the value of the address of n. They are the same, right? Because we are make a pointing. Okay, this one point to this one. Pointer p point to the address of n. And if you display address of p, this is address of p, and you will get the address where the p is located, right? And if you say the address of n here, we can get the location of where the variable n is located in the memory. Okay, so p here is 10, and this one is 1C. So you may ignore the what we type here in the box, because this out display from the program, right? Different memory, different computer may give you different location address. And this one just an example. I haven't get it from this program. Okay, just ignore this one. And when we say p, okay, when we display p here, because p store the address here, p store the address of n. So this one is the same, right? This one is the same. When we say these two lines, number 10 and 11, actually they are the same. Okay, this is the address of n. May erase the ink a little bit so we can see it easier. Okay, so this is the same, because this is one way to access address on normal variable, and we already set from line 7. So this is the same as we write this one. So we got the same address, right? Both of them are address of n. And when we try to access to the value of the pointer, okay, pointer store address, and when we want to know what is the value at that address, we can use star p here. Okay, star p. So the value here is 10, right? Okay, it's 10. That's a quick recall on the pointer, point to the integer. Do you have any question? Okay, if not, we will take a little bit more on the example. This is just a pseudo code on how to swap two number, okay? But there is a problem here, okay? As you can see, this is the main program, okay? This is the function, okay? This function called exchange. This is the name of the function, and it takes two parameters, okay? V1 and V2, okay? What it's trying to do is trying to swap number, right? You may have seen this kind of function before or not, I'm not sure. But the thing is, the idea is trying to exchange number. For example, now V1 should be changed to V2, the value. V2 should change to the value of V1, okay? And in the main program, as you can see here, you try to call to this function, okay? This is just a normal function that we have seen before. There is no pointer operation at all, because when we create a function, we can pass parameter, right? But this parameter is just a copy, a local copy. Whatever we modify inside the function, this value will not affect to the original variable before we passing into this number, okay? Before we pass to this function. Okay, so in here, if you exchange, we call to this function. This function is trying to swap, right? But it only swap inside the function itself. It does not swap to the overall case. This is only operation is performed only inside the function. After the function finish, all value of the variable will be destroyed, because this is the local variable in function. So what we get here, if we say a equal to 1, b equal to 2, and we call to this function, even this function trying to exchange, right? This is the code how we can exchange between the value, the two parameter. But when we write here, what is the value of a and b here? We still get the same, right? A is still 1 and b is still 2. This is the same here. It means that this one does not affect our variable, because this is only a change in the function itself. We will test to see that later on, but the idea is like the local. Okay, this is local, you pass it here, it may make a copy in function parameter, and then it's trying to do some terrain operation. After this operation finish, everything is destroyed. It does not affect to the original A and B here. Okay, that is the reason that's why we get still A is 1, B is still 2, the same to the original state here before we call to the function exchange. Okay? So this one is the value is the same, it's not update, so it does not what we want, right? Because we're trying to exchange, right? But if you use pointer, this is another way. We have a problem when we don't use pointer. We want to exchange two numbers using function. We cannot do that. But with pointer, you can create a function here. This is a function name. And parameter of this function is a pointer. You say star v1 and star v2. Okay. And inside this operation, you can write some logic in order to exchange the number, right? Because it is a pointer. So when we perform with pointer, we always use star here because this is performing value operation. Okay, value operation. Firstly, you back up the value of v1 to store in TMP variable. TMP is an integer, right? But if you say star here, it is value, so you can store that. So we back up the value of v1 install TMP. And next, we're trying to swap, okay? We change the number. We put v2 into v1. We put v2 into v1. And next, we put TMP back to v2, okay? That's how it works, that in order to swap two numbers. And as you can see here, once this one is called, okay, because this one is defined as the function with pointer, parameter is pointer, you see star here. So pointer is address. And this one is actually a normal variable. When you call to this function, the parameter that you provide here must be the pointer, right? Because this one is pointer, it needs to take a pointer. So we know that pointer is address. So simply just put ampersand, the symbol n preceding this variable. This will give us the address, right? Address of A, and this one is address of B, right? It's the same as when we put pointer. So this one will update. It will reference to the content, the data of this variable directly in memory. We do some operation here inside memory itself. So there is no local copy anymore. If you learn about function, when you pass with parameter, it make a local copy. Okay, but this one it will pass as a reference, pass address, and the function, the body of the function here, it will access to the memory location, do some operation, you update or you do something, and next the value that you obtain here, if you display. So just the command here, right? When you display, you will get this number is a change. Okay, before it's 1, A is 1, B is 2, and now A become 2 and B become 1. Okay, that's how what is the main operation that we can work with pointer. We can access to the memory directly. Okay, I think do you have any question? Next, we will go to coding to demonstrate these two functions together. Okay, no question yet. I think we go to the program. You can open your program, the C++ also. Create a new file here. Pointer change. Okay, pointer say swap.cpp. Structure of the program is a string using namespace. td main. Okay. So what you can try here like the first part without using pointer. Okay. Function first. how to create a function. Here is usually void the name of the function. Let's say change, or you can put swap. It's okay. So I say here is we say a comma b. We're trying to swap between a and b, but by using no pointer at all. Okay. So you say in order to change number, you say integer and tmp here. You make a backup tmp equal to, let's say, a. Okay, you back up a first, and next you say a equal to b. You put b into a. So now value of a is updated to b, right? And what is the old value of a? We already store in tmp. So we put it back into b. B equal to tmp. Okay, this is how we exchange, right? But this one is only done inside the function itself. If we test that, we can see the one number is not exchanged yet. There's the same because it's just a local copy. There's no access to memory location, so there is no swap at all, which exchange at all. We can test to see that. Let's say we have this number integer here, n1 equal to 5. We have n2 equal to 10. Okay, and then we call to this function exchange n1 comma n2. Okay, so we pass a local copy n1 and 2 to a and b here. Okay, so when this one get a local copy, it's trying to do something inside the function. Once the function finish its operation, the all local variable that has been copied, all are destroyed, all are deleted. Okay, so this is the same, like whatever we have n1 and n2 here, they are the same number. So you say here see out. Okay, see out n1, see out n2. Okay, and the is a new line. As you can see here, before n1 is 5 and n2 is 10. Okay, and when you after you exchange, when you call to this function, and finally you call to display just to confirm whether this number is now exchanged or not. Okay, as you can see when we run here, the number is still the same, right? Because we didn't exchange directly in address. What it changed from the body of the function from line 5 to line 10, as we have write tmp and then we back up something, we store the value of b and update tmp or something. This is only performed in the local. So now the value of a and 1 and 2 are the same, still 5 and 10, right? There is no update at all. Okay. This is the cause of the problem. Then we don't use pointer. Okay. So next we create another function exchange. Let's say exchange with pointer. Okay. With a little bit long name, but easy to read. A here and then we come in b, because it is a pointer, right? We can pass the parameter is a pointer. You say star a and star b, because it's the how we define the parameter as pointer. Because we know it's a pointer, when we perform operation, we need to use symbol star. Okay, star. So I can say a normal variable here. Let's say tmp. We want to back up this number, right? Back up this number. Okay, tmp equal to back up a number. You need to use star a here, because it is a pointer. You need a symbol star to get value, not address. And next, you update this number, right? Okay. So just following the previous here, you can update using star symbol. So I put a, update value of a by getting the value of b. You store it in the place of a, right? Okay. And the old a here is already kept in this tmp variable. So you can put it back to b. So star b equal to tmp. Okay. This is how we can exchange with pointer. We just need to familiar with the symbol star here when we use star, when we use address, so on. Okay, next we will call to this function to check whether this number is exchanged. You can just copy this one and call to this function instead. Exchange with pointer. Change pointer. Okay, when you call here, as you define, this is our parameter, right? This is a pointer. And when you call this one, as you seen in the red line here, because we haven't updated this one, it must be given as a pointer. Pointer is address. So we cannot just put N1 and N2, which is just normal variable. You need to put a pointer, okay? So you just put ampersand, the symbol here, and this is give us address, because pointer need address. Just put address. This one can, okay, we know that this is address. It is a pointer, so it can do this operation. Okay, as you can see here, we have we have four. The first two lines here is obtained from line 29 and 30, in which that we call to the first function exchange N1 and N2. We don't get any exchange number. It's still the same, right? N1 is 5 and N2 is still 10. Okay. And next we do some other operation with pointer at line 33 that we call to the function exchange with pointer. We pass certain parameter as address. Okay, so that means that the body of the function exchange with pointer will access to that address and do some operation that we try to swap to a chain number here. Okay, and finally at line 34 and 35 we get this number is update, right? And one now is changed to 10 and two now is changed to 5. It's the way we exchange between two numbers. Okay, I think, do you have any question? If I go too fast, you can inform me, it's okay. So any questions so far? You can try this in your program. Okay. If no question yet, I think before moving into next topic is we work with pointer and array. Okay, we will take a short break about 10 minutes, and while we are on the break, okay, you can try to test this program if you haven't finished it yet, and we'll share you the links to the lecture note in the chat box. So we will take a break for about 10 minutes, and we will come back at 10:50. Okay, 10:50. So it's the swap here. Breaks 10 minutes. That's 10:50. Okay. Okay. Hello, everyone. Can you hear me?
Hello, Mister. I can hear you.
Okay, thank you. So we will continue after the break. Do you have any questions so far?
Can I ask you something, Mr.?
Okay. Okay, please.
Uh, Maybe you have explained it before, but I didn't hear it clearly. But I just wanted to ask about how we make a pointer program. There are point to a variable pointer to. I mean pointer to pointer, sir.
Pointer to pointer, right? Okay.
Yes.
Actually, in here we haven't covered on that so far. It is about the double pointer. It's something we call two star. When we create a pointer, we can have a two star. But so far we haven't covered on that yet. This is maybe I can just put in here a little bit. It's somehow when you create a pointer, you say star star here, right?
Yes.
Yes. Okay. So far we haven't seen that yet. Actually, in here the main part, like, we don't focus much on that, but there is a slide. I think I haven't included that in the slide. This is how the relationship between one pointer to another. This one will point to another pointer and another pointer to a variable. So it means it's concerning about the double pointer. Like, if you are trying to access to the value, if you need to double here. I think I have something in the slide here. Let me put it a little bit here. Okay, I think I haven't put this one. Okay, this one. It's something related this one that we are talking about, the double pointer. We have a two-star symbol here. Like, if you say a double pointer here, it actually point to another pointer which is only one star, but it's one pointer to a normal variable. And this is how we can access to this number. It's just basically the pointer accessing to the normal variable first, and later on you try to access using double pointer, which is you take the address of pointer here, because this pointer p represent the we also have the address, right? You can get the address of p here, and then you store it in double pointer here, which is done by this operation. Okay? Just this one, and here, like the naming here, I put it pi. It actually in here it should be pi, right? This will be mapping into this example. Okay. Is it answer to your question?
So if we point to three pointers, that's mean we make three star on that pointer. Get
I
some,
think the three
right?
pointer is not exist. I think I'm not sure about this, but I think it's not exist with three star. It's allow only to double star.
Oh, okay, sir.
Okay. But just I mentioned, like, I'm not sure this, but to my understanding so far, we only have to double star here. There's no triple star yet.
Okay, sir. Thank you.
Okay. Actually, in the lecture part here, I haven't included that into the lecture part. I think it's mostly we don't use that. It's kind of quite too deep operation, and then normally if you're talking about the program nowadays, we don't really use kind of operation. That's why I didn't put it in the lecture note. I already removed that one. It's good, like you asked about this one. It's kind of confusing topics sometimes in here. Any other question? Okay, if you don't have any other question, we can move on to the next slide. We're focusing on the pointer and array. Okay. Maybe you have already familiar with this one. When you create an array, actually an array itself here, because array is a set of element, right? It has, for example, if you create 5 element array, and then each element, it also has its address. Just its address is next to each other. For example, if the integer takes 4 bytes, for example, the address from one position to another position will be different by 4. Okay, because each memory take 1 byte, so it will the number here if you different with 4 bytes. And the address of the array itself, which is it is taken from the first element address. As you can see here, this is the address, this is the array. Okay, let me check an in here. Okay, so this is an array. For example, this is an array. This array, it also have the address. The address is taken from the first element. This is the address of the array. The whole array does not have address actually. To make it easy, the array has no address, but it represented by the first element of the array, because each element here, it has its own address, right? So to get the address, we can get by the first element. Okay? And in pointer, we can put them together with array. You can create an array, and then you create a pointer, and then you point the array to this pointer. You point the pointer to the array, sorry. You make this pointer point to this array. This will point to the first element of the array. And there is a remark here. If p point to any element of an array, then p plus 1 will point to the next element. This is an operation of a pointer with array. If you say p point to any element, for example, if it point to the first element, when you say p plus 1, it will point to the second element. Okay. And because of using this operation, we can access to the array element without using the bracket. We don't need bracket anymore. We can just simply use this kind of operation and together with the star symbol. More generally, if we have P1 point to the E element, the position of the element here behind P, and P1 point to P1, P minus E is point to the E element before P, right? Okay. This is just you go forward and go backward by using the operation plus and minus. Okay. Suppose that we have an variables, let's say an array, which is tensile array. And we can assign the pointer point to this array by using this symbol, okay? By using this line. Just simply say P equal to A, or A and the array name here. We don't put something like here P equal to N array, because array itself does not have address, right? You can simply equal to here, it will get the, we don't need this one. We don't need the symbol N here. But when we work with primitive data type, so far we need N, right? We need N before the array name. But because it's array is special, this one we need the symbol N here, okay? This will allow us to point to the first element of the array itself, okay? And we want, if we try to display something, we put the command here, insert the code. If you want to display, we print F, we see out in C++. We can display the value of first element by using star P. Okay? If you say star P here, it will take the first element value for you. And if you say star P plus 1, okay? It will take the next element value. For example, if the array is, this is a number in array, we have 1, 3, 5, and 0. The size is 4. If we say star P, after we point this one to this array, star P is 1. Okay, star P, the value is 1. And star P plus 1, this is the next element, right? Next element the P, which is letter, which is number 3. Okay, we get number 3 here. So these two main operation is replace the what we call the bracket syntax using array. When we try to access the element in the array, we use bracket. So this operation can be replaced the bracket. Okay. And you can have an example here on how we work the pointer with array. And next we will back to the coding a little bit on how to. We can add a simple array. Let's say we initialize an array of size of 5. This is the number inside the array. We have 2, 5, 7, 9, and 0. 2, 5, 7, 9, and 0. Okay, this is the number in array, which is a here. We say it's a. Okay, and then we say we have p variable. Okay, this is a pointer, and you point this pointer into this array by line 8. So this means that you have p here. P it also have its address, something here, and then what it's doing here is trying to say 1f, 5f, something here. Okay, and this one will store 1f. This is the address of the first element. This one will point to this array. Okay, it's actually point to the first element. And when you say when you display this operation using star here, we get the value of p, because p now is pointing to the first element, what we have discussed earlier. P point to the first element, which is the number is 2. So when we display star p, we will obtain the number 2. Okay, so this one we get 2, because star p is the first element of the array. Okay, we got it's 2. And when we say star p plus 1, because we're trying to go to the next address, next element, right? So make sure that you put this in the parenthesis. If we say star p plus 1, this is different from what you write star and then p plus 1. You grouping and then you move to the next address. Okay, this is the right way. Okay, this one you're trying to sum the value at first element plus 1. Okay, this one you're trying to sum element at the first position plus 1. So make sure that you're trying to you use the correct syntax here when you try to access array element. Okay, and we can also access to the address here, a here. So in C++, it allows us to write both the variable itself and also the symbol n in order to access to this address of this array. Okay, it actually the first element array address. So which is obtained, and then we can. This is the result from this two. They give the same thing, right? But if you talk about the pointer it have its address and also the value that it store. So this the thing that different between array and pointer. And if you're trying to access the first element of the array, okay, you can say a here by using the bracket symbol. Okay, you will obtain this one. Okay. I think that is it for the example here, and there's a remark here. When you're trying to say p equal to a here, it will give you an error, right? The basic what you have learned from the primitive data type, so character, integer, or string. You can put to get the pointer point to that variable. You say, for example, integer. Let's say n here, and then later on you have integer p. This is a pointer p here. And then you say p equal to n. Okay, this is the right way using with the primitive data type to get the address, and then you store this in pointer. This is correct. But when you work with the array here, this is an array. You cannot do this. You cannot put this symbol n here, because array is considered as a pointer as well. That's why if you write this in your program, you will get an error warning in the compiler. You cannot run the program. Any question at this point? Okay, if no question, we go to the program and testing pointer with array here a little bit just to demonstrate. Create a new file. Oops. Pointer array. Structure of the std. Okay. So suppose that we have array variable, let's say a1. You initialize this array number. Let's say there are 5 in this array. Let's say 1, 5, 9, 0, -2. Okay, this is the number in the array. And you also have the second array, a2 here. Maybe the size is smaller. Okay, let's say only 3, and you have this number 2, 4, and 6. Okay. So this one you can have a pointer. Let's say you have p. Either you could add a p1 and p2. It's okay. You can point to either one of this. So let's say I have only a pointer p here, and I point to. Firstly, I point this one to p1. Okay. A1. Sorry. This is how you define it to point this one. And if you display the number here, p, let's say star p here, because we want to get the number, right? If you say only p, the address of the first element in the array. Okay, let me, we can put it both in new line here. Okay. So what we get here, this is the address of the first element in the array. This is the value at that address. Okay, you can run this one. Okay, this is the address of that element, and then this is the number, which is 1. And if we say, let's say we have another option, we put p plus 1. Okay, this is we are moving the next address, right? And this is the number here, you plus 1. Okay, you're trying to access to the data in the second slot of the array. Okay. Okay, as you can see the difference here, this is the address of the first element and the number itself, the value stored at the location. And this is give you the next address. For example, you have the first element and you have the second element, right? And as you can see here, the address here is different. This one is representation of the address. It ending with 00, and this one is ending with 04. Okay. The difference here is like why it is 4, why not 001? It's because that the integer takes 4 bytes. So one slot to another slot, the address it's okay. And the file here is got from this operation. Okay, we can get this one. And up to this point, we can move our pointer. Let's say p here. We can make it to point to another a2. It is fine, because we don't make a copy, right? We just change the pointer of p before we say that, okay, p now I wanted to point it to p2 so that I can do some certain operation to access the number from here. I can do that. And we just make this the same. Copy and paste here. Put some message. Working with a2. Okay. And this one is working with a1. Okay, so as you can see here, when we try to update the pointer before it point to a1, the number that we get, the address, and also the number, the value that is stored in that memory location slot for that array elements, we get different number. This one is 1 and this one is 5 because we point it to a1. And when we work with A2, let's say A2 below here, we change the pointer at line 24, update the pointer here to point to A2. Okay, so now when we point to A2, we get a different address, right? Because this is not the same from A1 anymore. This is the different here is like this one is FD. If you notice here, this is FE00 and this one is FD F4. It's the way the compiler assign the location memory. But the thing is, we know that it's different. It should be different from A1 and A2. And when we say the sequence element, like this is the first element, this is second heading here, the address, like they are different by 4 because this is 4 bytes. In the program or C++ here, the integer takes 4 bytes. Okay, so each element in the array they are different by 4. Okay, from one slot to another slot, the address is different by 4. Okay, do you have any question on this one? Okay, so in here, just an additional notice. If you trying to access all information inside the array using pointer, you can normally use loop, right? Just the way you access it, no using bracket anymore. So for example, if I want to display all data inside this one, okay, you can put it in here. Let's say you have make a for loop. Let's say for loop start from something here. Let's say from 0 until I equal to I plus 1. Okay, and then you see out this number. Let's say p plus I. Okay, p plus I. So if you put something right here, what's happening now is like you're trying to display right any element inside the array, but make sure the condition is not preceding the max number. So in here, just to demonstrate, the size is 5, but we're trying to sum up to 5, right? So this is 4, p plus 4. That means that we got the last location of that element. Yeah. Okay. Okay, this is number we get. What's something here? Okay, because we haven't pointed the p to any variable yet, right? That's why we cannot display this number. We get any strange number we don't know. We don't expect this number actually, because we haven't pointed this one to p1 yet. Okay, let's say p equal to a1. We point to a1. Then we run this again. Okay, this is the number that we get, which is 1590 minus 2, because we don't have any space separation. And to make it easy to read, we add some space here. Okay, space or a tape here. Okay, this is all content from the array A1. Is we can get this number using the pointer. It may be confusing if you're trying to use star symbol and with together with this one. Just this is the operation working with address. It's not address plus 1 or something. We cannot take address and do some operation with integer number. It's not. But this one just the way it move. Okay, it move from one slot to another slot of the array elements. Okay, do you have any question? Okay, if not, I think I will move back to the slide. We have a few slides left. I think only one left, and we have some practice that you can uh, do it at home just to recall the lecture. And this is another part, like the way how you can get what is the size, the maximum size of each data type using C++ command. We call it sci-f. Okay. So in this program, you're trying to inspect what is the size for each data type. The size here means the maximum number that each variable type can hold. And this number represents byte. So if you see that the size of char is 1, it means it is 1 byte. 1 byte is equal to 8 bits. 8 bits is representing by when if you do some mathematic operation, 2 to the power of 8, it is 256. Okay, you have 256 character that can be stored in the variable char. And you have integer. So the size of integer here, as you can see on from line 10, you can use the command sci-oft and you pass the data type in. Okay, because it's integer, right? You can pass the keyword in here. It will get you the size of this variable type, which is 4. Okay, so for here, what does it mean? It is 4 bytes, which is equal to 32 bits. 32 bits here, it gives you the ability that you can store the number into this data type to the form of 2 power 32. So the number 2 to power 32 here, when you display the number, it has the limitation as well, because you have the negative and the positive part. If you notice some program, when you try to store too much number, the number is too large, and then you only use integer, you will face a problem that your number will not get the right answer, because when the number is too high, it exceeds the maximum number for integer. And in that way, you should pick up the another data types that is big enough that can hold your number. For example, you have, you can put 2 to the power 32, 2 to the power of 32. This is the number that the integer can hold. Okay, 4,000 million something, and this number is not it cannot store up to this, because it need to divide by 2, right? Because you have negative and positive part. Unless you use the integer is unsigned. Okay, when you say unsigned, there is no negative including. If we get take all positive number up to this 4 million number, 4,000 million, sorry. So if you divide this by 2, divide by 2. So this is the each of the integer variable can hold, starting from negative minus from here to this up number. Okay, this is just how the number in each variable type can be stored in maximum size. I think you can test it in yourself in your program. I will not go back to the program. I mean, this is just very simple. You can use the sci command here. Just explain you how each variable type contain here. But in the older computer, if you use 32 bits architecture, computer OS, operating system is 32 bit. And you may use the compiler, the older version, and the integer here is not up to 4 bytes, it only 2 bytes. But if you see in a document, latest document, it's not 2, it's now updated to 4. Okay, so just make a note there. If you use a lower computer architecture and lower compiler, you may not get 4. Okay. I think that's it from me. We go. Do you have any question here? Any questions so far?
I think all clear, Mr.
Okay, sorry. What is your question?
No, I think all clear. No
All
question.
clear. Okay, okay,
Okay.
okay. So I think we go to the last part of the today slide. We have some practice. Maybe you can try it at home just to recall what you have learned here. And I think it's some of the exercise here I already show you in the demonstration, but you can adjust we make it the full description. You can try it at home. The first exercise is to create and initialize any value that you like. But what we need is we need 3 data types. We have float, integer, and string. Okay, and then you try to put any number, any value into variable. This is normal variable, no pointer. Okay, and next the goal is to display the value and also the address for each variable. For example, if when we create these 3 variables here, you have float assigned to a certain number, let's say 10.5. Okay, and you have another integer and string. Okay, and finally you display the address and also the number. We want to know, okay, this number 10.5, in which address that it's stored at. Okay, we want to see the address form here. It's simple, like just we create the variety of variable types. And in the second example, in the second exercise, sorry, you are asked to write a program in order to get 2 number from a user. So this user from user input, you can see in, can you see in command in the C++ language, or you can try with the scanf command using the traditional way of using a C command in C++. That's okay. And the goal is trying to swap them into your program. But in here, there's no need to use a function. Okay, you don't need to use function at all. You can try to swap them. So the swap here is actually really straightforward. You don't need to use a pointer. You can write some logic inside that, right? Okay. And number 3 here, you try to make it as a function. Okay, you will see the difference. Okay, when you make it as a function without pointer, okay, what you see is not what you expected. You're trying to swap to change 2 numbers, and when you make it as a function, it does not give you what you expect. What you expect is to get the numbers change, right? But if you don't use pointer in number 3 here, you will not get it. Okay, so in number 3 you can try 2 different ways. The first way is to try with without pointer. Okay, you will see the result. Okay, it's not what you want, and then you try to improve it by creating a new function. Let's say a function using pointer, and by using pointer operation, you will get what you expect for performing the exchanging between 2 numbers, which are passed from the parameters. I think that's. Do you have any question on this part? If not, I think that's all for today. Thank you everyone for joining the class. And we close the class from now. Okay, thank you.
Thank you, sir.
Okay,
you, sir.
you're welcome.
Thank you, sir.
Thank you, Mr.
Thank you, Mr. Channa.
Okay, and for the next topic, I think we will inform you later. The next planning topic is about sorting or something. Okay, sorting algorithm or something, and we will plan and let you know. Maybe not next week. We not see you next week. Maybe and other weeks later we will inform you in advance. Okay. So thank you everyone for joining, and we hope to see you later. Okay.
Thank you, sir.
Thank you, sir.
Thank you,
sir.
Mr. Channa. See you next week.
Thank you, sir.
Oh,
Thank you, Mr.
Thank you, sir.
See you.
okay. Goodbye, everyone.
Yeah.
Okay,
Thank
you're
you, sir.
welcome.